Good day. As the title says, Esterification, a detailed description. This gives you an indication of just how complex esterification is, and this kind of representation of the reaction mechanism is something you would encounter in university chemistry courses. You're going to do a lab, if you haven't done it already, and that is on esterification, and you're going to combine different carboxylic acids with different alcohols, but you'll catalyze it by adding some sulfuric acid. And the sulfuric acid will provide the H+, which allows the reaction to proceed along with some warming of the mixture. Now, since the H+ is a catalyst, that means we use it up in some step, but at the end we have to get it back. And that's why we don't need a lot of catalyst, we just need a small amount, because every time the reaction happens, we get our catalyst back. So here we're looking at our carboxylic acid, and the acid, what we see is it attaches to the oxygen and involved in a double bond to the carbon. And we get this unstable molecule. This molecule, we bring it down here, and now all of a sudden we introduce our alcohol. The oxygen, the alcohol, is going to attach to this carbon. And we get this very unstable chemical. So it comes along here. And then we say, well, what has to happen? Well, we see this overall, this has a plus charge in this region of the molecule. And the hydrogen leaves and takes the plus charge with it. And we end up with this. Again, it moves down here. And what happens is the H plus adds to a different location on the molecule. And you might say, oh, OH2 looks a bit like H2O, and you would be correct. So we have this, and the next step, the H2O flops off. So at this point, we almost have our ester. All that's left to happen is this H plus is going to disappear, and we will have our ester. And you'll see, okay, well, we got H plus back. That means it's a catalyst. We've generated the water, the dehydration synthesis, removal of water, and we can then attack and figure out what our ester is. Well, if we look at this, we had ethanoic acid, and what have we added to it? Somewhere we were adding our alcohol, which was methanol. So this is going to be methyl ethanoate when we're all done. So the alcohol becomes the branch, and the carboxylic acid goes, in this case, from being ethanoic acid to ethanoate. And anything that contains the carbon double bond to the oxygen in our ester is considered to be the main chain. So anyways, obviously you're not going to be responsible for all these kind of things happening. This is more for interest, and just let you know how complicated reactions are when we look at them in detail.